A blissful afternoon, young learners of mathematics. So, this afternoon, we are going to be learning about concept of factorization. My factorization. Factorization is a concept in mathematics that involves bringing out common factors out. That involves bringing out. That involves bringing out common factors out. Okay, we all know about HCF. Okay, so if you were asked to find the HCF HCF of 2 and 8, how do we go about it? Okay, we can use this approach of finding our HCF, finding a number that can go in all of them at the same time, and that number is 2. 2 goes in 2, 1, 2 goes in 8, 4. So in this case, our HCF is 2. So as we have found HCF for ordinary numbers, we can also find HCF for algebraic factors. For instance, if you are asked to find the HCF, of 2a squared and let's say 6ab. So let's use another method, 2a squared, using the prime factor method. 2a squared can be broken down into 1 times 2 times a times b, and our 6ab can be broken down into 1 times 2 times 3 times a times b. We look for what is common, so we have 2, and we have a. So in this case, we say the HCF is 2 multiplied by a. So HCF is 2a. So this is finding HCF of numbers. Now, this knowledge of HCF can be extended to factorization. Our factorization, it has different categories. We are going to be looking at it from the point of view factorization of the form ax plus b, ax plus bx, when we have an expression like this. So how do we factorize it? For example, if you are asked to factorize 2a squared plus 6ab, how do we go about that? So what we are going to do is to break it down. Our 2a squared can be broken down as 1 times 2 times a plus our 6 can be broken down into 1 times 2 times 3 times a times b. Then begin to look for what is common. I have 2 here, I have 2 here. I have a here, I have a here. So those things that are common, you bring them out. That's 2a into brackets. You now multiply those things that you do not that is not common. So we have 1 times a, that's a, plus 1 times 3 times b, that's 3b. And this is the factorization of this expression. If you want to check whether you are right or you are wrong, to check, expansion is the opposite of factorization. To check, we expand. So when we say 2a multiplied by a, that will be 2a squared. 2a multiplied by 3, that will be 6ab. So once you expand and it goes back to the original question, then you know that you are correct. Okay, let us see further examples. If you are asked to factorize 3p plus 5p square. 3p plus 5p square. So we'll break it down. Our 3 can be broken down into 1 times 3 times p, plus our 5p square can be broken down into 1 times 5 times p times p. Then we look for what is common here. So p is common, p is common. If you say 1, If you remove 1, you can always find a 1. So there's no problem with 1. So we bring out that is common, which is p into bracket 1 times 3, that's 3, plus 1 times 5 times p, that's 5p. So this is the factorization of that expression. Like I said earlier on, if you decide to expand it, p times 3 will give us 3p. P multiplied by this will give us 5p squared. It goes back to the original question. So this is how to expand expressions in that order. Okay, so let us, having understood that, I want you to carry out this expansion. Factorize a 2by plus 6b squared y, b 3ay plus 12a squared y, c 2x squared y plus 24x squared y squared. Then d 3pq 3p squared q plus 39pq. So factorize that and drop your answers in the comment section. Now, having understood that, the other one we are going to look at this afternoon is factorization of difference of two square. Factorization of difference of two square. Factorization of difference of two squares. What do we mean by two squares in mathematics? Two square means that a number that has a square and another number that has a square, they are different. So in mathematics, difference of two square means taking away of two squares. A square minus b square has been proved to give us a minus b into bracket a plus b. Now, if you want to check whether this is right or wrong, let us see. By the time you expand this bracket, let us see whether it goes back to a square minus b square. Okay, so let us try to expand it. A multiplied by a will give us a squared. A multiplied by b will give us plus ab. Minus b multiplied by a will give us minus ab. Then minus b times this will give us minus b squared. And plus ab minus ab is just like plus 1 naira minus 1 naira. Have 1 naira and more in 1 naira. They automatically vanish. So we have a squared minus b squared. So therefore, the expansion, the open bracket a minus b into close bracket a plus b is sufficient for a squared minus b squared. So how can we see this in questions? You can be given something like this. That's okay. Factorize x squared minus 9 squared. Following the principle of difference of two squares, this has a square, this has a square, we are finding their difference. That the expansion, the factorization is nothing but x minus 9 into bracket x plus 9, and that sums it up. That's the factorization, that's the answer. Okay, let us see further examples under factorization of this form. Let's say we have x squared minus 1. We are asked to factorize this x squared minus 1. Of course, we will agree with me that this one has a square, but this one does not have a square. So you have to make it look like something that have a square. Don't forget that x squared minus 1 is the same thing as x squared minus 1 square. 1 square will still give us 1. So the factorization of this will be x minus 1 into brackets x plus 1. Are we together? Let us see about two examples before we call it a day here. So we can also have factorize y squared minus 25. You will agree with me that it wants to look like difference of two square, but it's not yet totally difference of two square. Our 25 does not have a square. So what can we do to make it have a square? Y squared minus our 25 is a perfect square. it can otherwise be written as 5 square. So now that we have been able to write both as square, we now have it as y minus 5 into brackets y plus 5, y plus 5, and we have just been successful at doing that. Okay, let us say one more example before we call it a day. If you have 2a squared minus 64, you are asked to factorize this. So how do you go about it? Don't forget that this entity already has a square, but our 64 does not have a square. So you can do something like this. Okay, this can be written as 8 square, and both already have a square. 2a has a square, 8 has a square. So following the rules of difference of 2 square, we can have it as 2a minus 8 into brackets 2a plus 8, and that answers the question. So under this difference of 2 square, I want you to factorize this. So I want you to factorize y squared minus 9 squared to b squared minus 36 number 3, k squared minus 81, number 4, p squared minus 100, then the last one, y 2y squared minus 100. So I'll see you on the other side. Bye for now.